Good day, class. In today's class, we want to continue our topic on percentage composition, but we'll be moving further on empirical formula and molecular formula. What is empirical formula? Empirical formula is the simplest formula which shows the ratios of the numbers of atoms present in the molecule of an element, while molecular formula shows the actual number of atoms present in the molecule of it shows the actual number of atoms present in the molecule of a compound. So today we want to examine how to calculate the molecular formula, determination of molecular formula from the percentage composition. In the last class we have talked about percentage composition. So we want to see how we calculate the molecular formula from the given question on the board. We have an organic compound containing carbon, hydrogen and oxygen contains 62.1% carbon, 10.3% hydrogen and oxygen. If its vapor density is 29, calculate the empirical formula, the molecular formula of the compound. Note, in this question you were given vapor density. Note that to calculate the relative molecular mass, you just say relative molecular mass is 2 times vapor density. Don't forget that. So let's continue with the work. We're giving the mass of the compound as elements in form of percentages. So we have 62.1% carbon, 10.3% hydrogen, and the percentage for oxygen is not given. So we know that the total number of oxygen, the total number of percentage in the compound is 100. But we are giving 62.1%, 10.3%. So we can calculate that of oxygen by removing it from 100. When we add up 62.1, we add 10.3, we take it from 100, we will actually get what? That of oxygen. So we say oxygen will be 100 minus the addition of 62.1 plus 10.3. So and that will give you, if you do it very well, 500 minus 62.1 minus 10.3. So if we do it very well, we have 27.6%. 27.6%. So that is percentage by mass of oxygen. So we set up our work. Let's first of all calculate the empirical formula. So we set up our work as carbon, hydrogen and oxygen. Carbon, hydrogen. So we have carbon, hydrogen and oxygen. So let's look at what we're given in the question. We're given 62.1%, representing their given masses invariably. So we say giving mass or giving percentage and mass are almost equivalent for this course. So giving data, okay, let's say giving data, we have 62.1, we have 10.3 and 27.6. The next stage you do is to divide by the relative atomic masses. Divide by relative atomic mass. Relative atomic mass of carbon is 62.1 divided by 12. Hydrogen is 10.1. 10.3 divided by 1. And we have oxygen is 27.6 divided by oxygen is 16. So if you do that very well, you have 62.1 divided by 12. We have 5.18. That of hydrogen, that's 10.3. Then we divide it by 1. And we have the next one, 27.6 divided by 16. We have 1.73. So the next one is divide by the smallest. So divide by the smallest. So if we divide by this, out of these three, 1.73 is the smallest. So we have 5.18 over 1.73. 10.3 divided by 1.73. 1.73 divided by 1.73. So if we do this very well, we have 1.73 is 1. So we have 5.18 divided by 1.73. We have 2.99. We have the next one, 10.3 divided by 1.73. 1.73. So we have 5.95. So these are the data we have. So we can approximate 2.99 is approximately 3, 5.95 is approximately 6, and we have 1. So the empirical formula of the compound is actually carbon is C3, hydrogen is H6O1. So this is the formula, empirical formula. But we're asked to calculate molecular formula given the vapor density. So from here, we know that molecular formula is empirical formula into bracket N. So molecular formula is given as empirical formula, that's C3H6O1. So we have C3H6O1 into bracket N, which will give us molecular formula is 2 times vapor density. So 2 times our vapor density is 29. So if we do 2 times 29, we have 58. So our aim is to calculate N, since molecular formula is the actual number representing an actual formula in a molecule of a compound. So we have carbon here is 3 times 12, see what I'm doing, plus hydrogen is 6 times 1, that's 1 times 6, oxygen is 16, that's 1 times 16, everything into bracket N will give us 58. So let's do this very well. We have 3 times 12, that's 36, 1 times 6, 6 plus 1 times 16, 16, and equals to 58. So let's add up now. We have 36 plus 6 plus 16. So we actually have 58N. So 58N equals to 50. So to get N, we divide by 58. So our N will be equals to 1. So I'm coming here now. So our molecular formula, we have to come here now, will be C3, which is this, H6O, our N is 1, so is 1. So this is the molecular formula. I hope you have gained something in this video. See you in my next video. Bye.